Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the AC values from the Chapter 15 Math handout, problem number 23. The first step I take is to fill in my known values from the Chapter 15 Math handout. So I see here that I have 36 volts VT, and I have my resistance values. So when I look at the circuit here, I have two what is called series parallel strings. I have R1 in series with R2, and I have R3 in series with R4. So the first step that I'm going to take is I'm going to combine R1 and R2 using the series rule to get R12. So I'm going to take the 100 ohms and the 200 ohms, I'm going to put them together. These two are added together to get this value of 300 ohms. Then I'm going to take the 680 ohms and the 220 ohms, going to add these two together, and that is where this value comes from of 900 ohms. So the first step I take is to add R1 plus R2 because they're in series, put that value here. Then I take R3 and R4, I add them together, and I put that value here. So these are my first two steps. Now I have a new circuit here, drawing B. This is really the drawing that you have to work from to find the values. So now I have 300 ohms in parallel with 900 ohms. I'm going to take the 300 ohms and the 900 ohms, and I'm going to apply the reciprocal formula to get my RT of 225 ohms. So I say 1 over under 1 over under 300, scroll over, plus 1 over under 900 gives me 225 ohms RT. Now I can find IT if I want to. It's not really going to help me very much, but let's say I go ahead and knock that out. So I take VT divided by RT, and that gives me my IT value, but then I'm stuck again. So the way to unlock this circuit is you take the VT value here of 36 volts and you apply it across what we call branch number 1. So my V12 in branch number 1 is going to be 36 volts. My V34 across branch number 2 is going to be 36 volts, because here when we get through with the calculations in a little bit, when we take V1 plus V2, it'll add up to 36 volts. And when we take V3 plus V4, it'll add up to 36 volts. So we understand that across both of these resistors, 36 volts will be dropped, represented by this resistor. And across both of these resistors, 36 volts will be dropped, represented by this resistor. So I take that 36 volts and I apply it across R12 and across R34. So we finish this, we combine to get our RT. Now we take step 4, we apply the VT to R12 and use Ohm's law to get the value of I1/2. So I take the V12 of 36 volts divided by the R12 of 300 ohms, and that gives me an I12 value of 120 milliamps. Now just hold on for a minute, just keep focused on this circuit. Okay, now I'm going to take the 36 volts divided by 900 ohms, and that's going to give me 40 milliamps. So I understand that flowing through this branch will be 120 milliamps from this point to this point, and from this point to this point will be 40 milliamps. So from point B to point E is 120 milliamps. That tells me that I1 and I2 will both be 120 milliamps, because whatever current, the total current leaves A and gets to B. Some of the current will turn at B and head towards point E here. Whatever current leaves B headed towards E, it all must flow through that branch through both R2 and R1. All right, some of that current is going to keep going from B to C. It's going to turn here, and it's going to go from R4 to R3 to point D and go back to point E. So whatever amount of current goes this way, that amount of current has to flow through both R4 and R3. So that 40 milliamps has to go through I3 and I4. And if we add I1 and 2 together, never mind, I'm getting ahead of myself. All right, so now we can find our voltage values just using Ohm's law, just simple Ohm's law. V1 is equal to I1 times R1. V2 is equal to I2 times R2. V3 is equal to I3 times R3. And V4 is equal to I4 times R4. So what we did here, once we got the resistance value for R1 and 2, by adding R1 and 2 together, we applied our total voltage to this branch. We divided it by that resistance, and that gave us the current that would flow through both of these resistors. So you apply the VT to R34 and use Ohm's law to get the value of I34. You apply VT to R12 and use Ohm's law to get the value of I1 and I2. The main point is, as long as you apply VT across the value of resistance that you came up with by adding R1 and 2 together, and then here you have the value of R3 and 4 added together, that will give you the current flow through each branch, and that tells you how much current will flow through I1 and I2 right here, 120 milliamps, through I3 and I4, 40 milliamps. So now we're going to apply the appropriate AC formulas to get the AC value. So I'm looking for IT peak. I take my IT RMS of 160 milliamps times 1.414, and this gives me my IT peak value of 226.24 milliamps. Now I'm looking for my V1 peak to peak. I take my V1 RMS value here of 12 volts. Remember, all of these volts and all of these currents are RMS values. So I take this V1 RMS value of 12 volts times 1.414 equals 16.96. That's my V1 peak value. And then when I want to find peak to peak, I just say peak times 2. So I just take this peak value times 2, and that gives me the V1 peak to peak. Next, I'm asked for VT RMS. Well, all of these are already in RMS, so VT RMS would just be the 36 volts VT. Okay, so let me walk back through it one more time. It's a basic combination circuit, so the first thing I'm trying to find is RT. I look here. And I understand that R1 and R2 are in series. So I'm just going to add R1 plus R2 to get this 300 ohm value here. Then I'm going to take R3 plus R4. That's going to give me this 900 ohm value here. Now I've got two resistors in parallel. I apply the parallel formula to the 300 ohms and the 900 ohms. That gives me my RT of 225 ohms. So here we combined R1 and R2 using the series rule to get the R12 value. We combined R3 and R4 using the series rule to get the R34 value. We combined R1/2 and R3/4 using the parallel rule to get RT. Okay, our next step here is to stay focused on drawing B. You're going to apply whatever the VT value is to this resistor and to this resistor. So now we have a V1/2 of 36 volts and a V3/4 of 36 volts. We're going to take that 36 volts, we're going to divide it by this 300 ohms, and that's going to give us 120 milliamps. We're going to take this 36 volts, we're going to divide it by 900 ohms, and that's going to give us 40 milliamps. So here we applied the VT to R1/2, and we used Ohm's law to get a value of I1/2. I1/2 equals the I1 and I2 value. Once you find I1/2, that tells you the value of I1 and I2. We applied the VT to the R34, and we used Ohm's law to get the value of I3/4, which is I3 and I4. So we took 36 volts divided by 900 ohms. That gave us 40 milliamps. I3/4, which is equal to I3 and I4. Now we can use Ohm's law to find IT, to find V1, V2, V3, and V4. Then we apply the appropriate AC formula to find our AC values. Okay, I have down here use basic power formula to get all the power values, but we're not going to do power in AC. I didn't notice that that was on there until just now, so you can just disregard that. You see we don't have a column here for power anyway, and we haven't been doing power on any of them, so don't worry about power.